Okay, number 3, we have a demand and cost type problem. And we're given that the demand function for a particular item is right here. And remember, demand is the same thing as the price. And we're told, we're not given a cost function specifically, but we're told in words what the cost is. It costs the company $10 to make each item, and the operating cost of the factory is $1,000 each day. So from that, we can write our cost equation. So per item that the company makes, it costs them $10. So that means that part of the cost is 10x. And the operating cost of the factory, that's independent of how many items they make. So that's just added on every day, and that's 1,000. So our cost function is 10x plus 1,000. So we have price and we have cost. And our objective in letter A is to find the profit. Profit is revenue minus cost. We have cost. Revenue we can get from multiplying price or demand times x. So our revenue function, which is x times p of x, would be negative 1 over 50 x squared plus 20x. And therefore our profit function, capital P, is our revenue function minus our cost function. So we have negative 1 over 50x squared plus 20x, subtracting our entire cost function, 10x plus 1,000. So if we combine and simplify that, we get our final profit function to be negative 1 over 50x squared. We have 20x minus 10x, which is plus 10x. And we have a minus 1,000. So this is our profit function, the answer to part A. So part B says how much should the company sell its item for in order to maximize profit. So in other words, we want the price that they should be selling their item in order to maximize profit. So you can tell here our profit function is a quadratic. There's a squared x constant, or a single power of x constant. First term is negative, meaning this is an upside down parabola or a infinitely negative parabola. So the one maximum we can find will be the vertex. So if we set this derivative, we take the derivative, set it equal to 0, the one thing that we will get is in fact a maximum. So we'll do that, p prime of x. So taking the derivative here, we get negative 1 over 25x plus 10. And we want that to be 0 in order to give us the maximum. So if we add 1 over 25x over and multiply by 25, we get that x equals 250. Now note, that's not the answer to this part, because that says if we make 250 items, we'll maximize profit. The part B said, how much should we sell the item for? Well, that would be the price, which is here. But since we know x now, we can plug that in and find the price. So if we plugged in 250 to p, so we want little p of 250. So that gives us the price per item if we sell 250 items. 250 divided by 50 would be 5. So we get negative 5 plus 20, which is 15. So this is the answer to part B. So if we sell for $15, we'll end up selling 250 items. And if we sell 250 items, that's how you maximize profit. So part C says, what is the maximum profit in a day? So we figured out that if x is 250, that's how we maximize our profit. But part C is saying, how much profit do we actually make when we do that? And that is just plugging it back into our actual profit function. We're saying, what is our profit when x is 250? We just plug 250 right into here. So for that part, we do capital P of 250. Because remember, that's in terms of x, and x is 250. So we don't really need to figure out 250 squared because we know we're multiplying by 1 over 50. So 250 divided by 50 is 5. So we get 5 times 250. Excuse me. Which would be 1250, and that's negative. We get 10 times 250, which is 2,500. And we have minus 1,000. So we just need to figure out what that is. This would be minus 2,250 altogether. 2,500 minus 2,250 would be 250. So if we sell 250 items at $15 a piece, the amount of profit we would make is $250. And that, again, I got by plugging our amount of X back into the profit equation right here.
The Teaching Center, UF's Learning Resource Center.